then that means either I am at home sick or you have been absent from class and you are trying to catch up. So either way, this is day 2 of 4.7. And the first thing I want you to do is I want you to go ahead and complete this warm-up right here. I want you to really complete it. So you're going to pause the video, and then when you unpause, then I'm going to go through it and make sure that you understand this learning goal, which was the student will understand function notation. So pause now. All right, so you have unpaused and you are back so that we can go over the learning goals from yesterday. If I can not get this to unzoom. Okay, so the first one said f of x is equal to 8x minus 4 when x is -3, 0, and 2. Sorry. Okay, so what I told you guys yesterday is to go ahead and put it into a table. As I said, I thought that would be easiest, and then you're going to plug each of these in for your x term. So I'm going to plug -3 right in here for x. So 8 times -3 minus 4. So that's -24 minus 4, which is -28. Plug in 0 right here. So 8 times 0 is 0. Minus 4 is -4. And if I plug in 2, 8 times 2 is 16. 16 minus 4 would be 12. So those would be your 3 answers. Okay? And sometimes the book is just going to have 3 answers here. Sometimes it's going to have them as ordered pairs. You have to know each of those is okay. All right, and the second one says find the value of x. So remember that when it says find the value of x, we don't know what x is. So if they say g of x equals -2x plus 1 has a value of 3, that means this, we are finding this. That's what that word find x means. So this gets plugged in over here. So that is -3 equals -2x plus 1. I'm going to subtract 1 from both sides. So I have -4 equals -2x. Divide both sides by -2, and I get that x equals 2. Okay, so that is your warm-up. Now, next part then would be to go check your homework, and I have posted the answer key on D2L, so you can go ahead and open up that homework, and you can go ahead and check that, and then save questions for me. Just put a little question mark by it, and then I'd be happy to go over that the next time I see you guys. All right, so moving into the lesson, you guys should have just checked your homework, and now we're going to look at a couple of these that are on the back. And the first one I want to look at is number 23. And this says to graph the function, but the biggest new thing we're going to talk about today is how do you compare your graph to the graph of f of x equals x. Okay, so what I call this right here, or what it is called, is this is called the parent function. And just like you guys have parents, you guys will look similar to whoever your parents are. So these graphs should all look similar to the parent, and they're all spawned from the parent. So you can think about this like a child function. Okay, it's not really a child function, that's just what I call it. So the first function was f of x equals x. So we're going to graph this. You're going to pretend that that is no different than y equals x. Okay, that would be direct variation because it goes through 0, 0, and then our slope here would be 1. So we would go ahead and say, okay, the parent function, which is always the parent function, has a y-intercept of 1, and it has a slope of up 1 over 1 each time. So that is the parent. Okay, now we need to graph number 23. So again, pretend that that's just like a y equals x minus 4. So the slope is 1, and the y-intercept is -4. So this would be -4. So this is going to go up 1 over 1, up 1 over 1, up 1 over 1. And this is the function, and we're going to label it, this is h of x. So see, this is one reason we do function notation, because now we know this is h of x, and the parent here was f of x. Okay, now we actually need to compare it. So you're going to have to say some things about it. Okay, so first of all, you notice that their slopes are the same. So these two are parallel. Okay, you're always going to talk about, sometimes you're going to say that the slope is more steep or less steep. So those are some things you can say on other graphs. More steep, less steep. They're going to, or parallel. Sometimes graphs will change direction. Because if it is a positive slope, it's going to go up, or if it's a negative slope, it's going to go down. So you need to say any combination of those that is true, where this one is just parallel. It's not more steep or less steep, it's parallel. Okay, so parallel. Then the next thing you're going to talk about is if there's been a shift up or down. Okay, this one, since this is the parent, it is shifted down 1, 2, 3, 4 units. So you're going to say shift down 4 units. Okay, and that's just the way that mathematicians say it. They say it shifts up or shifts down, and later on we'll talk about things that shift left and shift right, but right now we're just talking about shifting up and down, okay, because that's its y-intercept. So those would be the only things you would say on this one. Okay, all right, the next one I want to look at is, let's go ahead and talk about 28. So I'm going to come over here to 28. All right, so like I said before, the parent function is never going to change. So the parent function is still the f of x equals x. So it is still located here because your parents never change. All right, then we're going to go ahead and graph n of n. Oh, I need to label this f of x. Okay, so this would be no different than if I ask you to graph this. Okay, and again, that would be direct variation because the y-intercept is at 0. This would be the slope -2/1, and this is rise over run. So I'm going to go down 2 and over 1, down 2 and over 1. I could also go up 2 and left 1. Okay, all right, so let's look at what we need to talk about here. So we need to go back and think about what we did on the first one. We need to talk about, is this more steep, less steep, does it change direction, or is it parallel? Okay, well hopefully you can tell on this one, this line is going to be more steep than this one, so we're going to say more steep. Okay, we also should notice that the parent was going this way, and now the child or the new function is going this way, and I need to label this one. This was what, n of x. And so we're going to say that it changes direction. And the last thing you need to talk about is if the y-intercept shifted up or down. Where if I look at this one, obviously it's the exact same intercepts. There was no shifting this time. So there's nothing that I need to say about that. Okay? So just in review, things you need to talk about. More steep, less steep, if it changes direction, and then you always need to talk about if it's shifted up or shifted down when you're talking about comparing. Okay? All right. If you have any questions, just let me know. Thanks, guys.